This is a Pinzgauer. More specifically, a 1973 Steyr Puch Pinzgauer 712M 6x6. How can I describe this thing? Well, actually, I like what AI says. The Pinzgauer 712M is a legendary Austrian 6x6 military off-road vehicle, known for its extreme terrain capability via portal axles, locking differentials, and a robust air-cooled engine, often seating 10 to 12 people or cargo, making it a versatile and durable choice for military, overlanding, and specialized use. And it is. If you like engineering, cars, the outdoors, or adventure, you can't not like this thing. You can't really tell from this angle, but this is a hill climb that basically only dirt bikes and a very small number of specialized vehicles can get up. And at the top, I mean, these pictures say it all. So what's with the video title about converting this thing to an EV? Well, my engine was starting to have various problems that required attention, and I found that when it went for a few months without use, that I would be spending more time than I wanted to maintaining it rather than driving it. And I've always been curious about custom EV conversions, so I decided to have mine converted. This video series describes the roller coaster that has been this conversion. Suffice it to say that things did not go to plan or schedule. I had to learn a lot, actually much more than I'd expected, given the fact that I actually started out by hiring a company to do the conversion. But yeah, I now know much more about modern CAD, splines, high voltage wiring, drive shafts, and I'm still learning. Spoiler, I am finally driving around in a fully electric Pinzgauer. Buckle in for a creative engineering project. Alright, so what was the plan? Let's take a more detailed look at the undercarriage of the 712M to see. It looks straightforward, and as custom conversions go, I think it actually is. The engine sits here, actually under a removable cover in the cab between the driver and the passenger. It mates with the 5-speed transmission, which is here, mounted to the central torque tube. It drives the transfer case via this drive shaft. The transfer case itself has a high and a low gear, as well as a neutral. So mechanically, this shouldn't be terrible. Rip out the engine and transmission, mount an electric motor to the torque tube where the transmission was, and mate it to the drive shaft, keeping the entire transfer case there. Plenty of space for electronics where the engine was, and throw some batteries into the side-mounted cases. And that's basically what we did. And it was difficult, because engineering is iterative, and moving a few thousand-pound machine at even moderate speeds, or up a 45-degree incline, makes high demands of materials and precision. So let's get into the conversion. First, the engine comes out, not a big deal, and underneath here you can see the transmission before removal, and the old exhaust on the floor. And here the transmission is out, and voila! The rear mount adapter for the new electric motor is already mounted to the old transmission mounts. And just like that, the motor is mounted. It's amazing how you can compress months of work into 10 seconds. And maybe now is a good time to talk about why, even though this mount seems great, it is no longer on the truck. As I said, I started this project by hiring a company to do this conversion. I hit it off with the owner, a really smart guy who had lots of interesting EV stuff going on in his garage. As the conversion progressed, I would periodically get pictures or video of milestones and other interesting updates. Unfortunately, in his own words, he just wasn't that great at running his business, and ultimately the business failed. I ended up needing to pick up the truck as what was basically an unfinished rough draft of the conversion. All the major parts were in and you could drive it, and it was designed well and conceived well, but yeah, major problems began appearing pretty immediately. And this wasn't a surprise to either of us. The owner actually told me that he thought I should rent a flatbed to get it home, but if I was going to be taking this project over, I wanted to have a deep understanding of what state we were in, so I opted to try to drive it home. I recruited a friend who is up for adventure, and with his help in a chase car, which was capable of helping recharge my low voltage system along the way, I actually drove it home 60 miles over the course of 2 days, fixing it along the way. On the first day, the strategy was to stop frequently to examine things, and almost immediately it was obvious that a small ATF leak I was told about was very significant when actually driving the truck. Even though the entire drivetrain is visible, just like the shop, I couldn't easily identify where it was coming from. The next thing started after a mile or so. Above maybe 15 miles an hour, there was a major vibration. If I pushed through it to 20 miles an hour or so, it would go away, but return with a vengeance at maybe 35. We tried a number of things. Here, we're adding grease to the drive shaft, for example. But we couldn't identify the cause or get rid of the shaking on the trip. So I found that if I accelerated up to about 30 and then coasted down to 20, that the shake was minimized, so I just drove like that. We arrived at our halfway point in the late afternoon, and here we are at the end of the day, backing it into another friend's driveway, where we could give it a more thorough looking over and a charge of the high voltage batteries overnight on a Tesla L2 charger. That closer inspection revealed that the shaking was enough that all of the motor mounts had come loose. This picture is from halfway through day one. I hadn't noticed yet, but this bolt on the front mount was starting to back out. This one here was still okay. This picture is from the end of day one. This bolt has backed out a lot more, and this bolt, well, is gone. The same was true of the bolts on the rear mount. They were all loose too. And again, no hard feelings with the company doing this conversion. Businesses fail. And they weren't finished. It's just important to see what the condition was at pickup in order to understand this engineering effort and what it took to go from a rough draft to a complete project, and what engineering problems I had to solve. I say I had to solve, but in reality, the business owner continued to help me for some time by lending me tools, parts, and even his own engineering time, getting me up to speed on the CAD program he used. Anyway, the second day drive was uneventful. I stopped a few times to tighten things, add ATF, and inspect. We got the truck home, and it was time to get to work. Now at this point, the project was basically mine to complete. The two things I attacked with the highest priority were the ATF leak and the drivetrain vibration. In the next video, I'll go over how I identified the leak and the vibration and what I had to engineer in order to make the drivetrain solid. But check this out. I've already posted the second video in this conversion, but don't forget to like and subscribe so you won't miss the next creative engineering project.